Have you ever seen broken connection on the working PCB caused by oxidation inside vias, like in my t-shirt? The PCB board was soldered at manufacturing, tested and sent to the customer. And a few months later the customers come back with a problem. The PCBs stop functioning properly. In this video I will explain why it's very important to cover vias with solder mask. A via is used to connect traces between layers of a PCB. Let's go step by step. First, molten solder flowing from a pad into an open via. One of the biggest design mistakes is placing a via inside a pad for soldering. During soldering or reflowing solder paste, the molten alloy flows into the via. This causes defects, not enough solder on one side of SMD component, which often results in the tombstone effect. You will find video about that in the description. Too little solder alloy on one side of the components will lead to cracks from vibration, and the component loses a reliable connection. Of course, this kind of PCB will have to be manually reworked to add the missing solder to the component leads. That's all added cost. If open vias are located under BGA, this can become a major problem if solder flows from the BGA ball joint into the via. The vias should be moved outside the pads and covered with solder mask on both sides of the PCB. If the vias is large enough, PCB manufacturers use different resins to fill the vias and then apply the mask on top. You need to take this into account when ordering PCBs. Write in the comments how often you run into mistakes like this. Second, soldering flux flowing into open via. Soldering fluxes vary, but even residues from no-clean flux can absorb moisture over time, especially when the device operates in a human environment. Even without flux, empty vias are still subject to moisture exposure. Moisture triggers oxidation and corrosion inside the vias. In this case, the copper inside the vias will eventually rot, and the PCB will stop functioning properly. Now imaging a PCB assembly manufacturing using cheap Chinese soldering paste with unknown flux inside. If the flux is active, its residues in the vias will quickly trigger corrosion, and the copper in the vias will oxidize. If you're soldering PCBs using wave soldering technology, then via stenting becomes especially important. Always take this into account when designing electronics PCBs. This is called via tenting. Do you use via tenting in your project, or do you think it's unnecessary? What flux classes do you use? There is a video about flux classification in the description. Check out the channel, you might find something else interesting and useful there too. I provide consulting services for electronics manufacturers, help with PCB defect analysis and soldering issues in the production. Like this video and subscribe to my YouTube channel. Share this video with the colleagues if they still leave vias open. You will find links below for consulting, industrial PCB repair, my Instagram and Patreon. Thank you for watching. See you next time.